Welcome back, students, back to my course, and let's start making a tutorial, basic raster operation. So at first, open the document, a Word document, basic raster operations, and also open ArcMap document, tutorial 6, basic raster operations. It looks like this. So here we have four data frames. And let's start from the beginning with local operations. I hope you're already familiar and watched the lectures and know how the basic principle of local operations. So open ArcMap document. First, activate the spatial analysis extension. Click tools in the menu bar. Click extensions and check spatial analysis. These extensions allow you to use the spatial analysis tool for geoprocessing of raster datasets. So in case you do not your spatial analysis toolset is not activated, go to customize extensions and see that my spatial analysis toolset is activated. Here, spatial analysis. In case if you didn't just already installed ArcGIS software, I think your spatial analysis toolset is not activated, and you should just activate all your extensions, because in case you didn't activated it, you will be not able to make raster operations and use this spatial analysis tools. So, and let's go first. Activate data frame local. The dataset elevation contains elevation values expressed in meters. Create a new raster where elevation is expressed in this DE centimeters and give it the new name. So it's 1 DE is 1 DE is equals to 10 centimeters. So how we can do this? So here we have we can just deactivate. Here we have our elevation raster, see, and it's continuous. It doesn't have attribute table, and it has a floating point pixels, which represents the elevation, the topography of the certain area, and how we can convert them from meters. There, here you can see in meters from 1.4 and to almost 47 meters. You can convert them into decimeters. You should so every pixel contains a meter elevation value in meters. So you should work with every pixel independently, because one pixel value doesn't depend to another pixel value. In this case, it's not hard to understand that this is a local type of operation, and we can use a raster calculator for this. At first, open spatial analysis tools, map algebra, you can see here, and see that we have here a tool, raster calculator. So one of the advantages of raster calculator is that it is able to work with one and more input rasters. Here we have only one input raster, elevation, right? Elevation, and we're working with each pixel independently. And raster calculator as a local which belongs to local operations tools, works with each pixel independently, and the output pixel values will spatially coincide with the input elevation. So we take elevation from the layers and variables here, and we just multiply to 10, because in 1 meter there's 10 centimeters. So and here we should find the it automatically gives the output raster. You can change it, but I do not recommend to change, because sometimes the ArcGIS shows the error when you try to change the default database where your output will be stored. So elevation multiplies 10. So let's just make a snip using snipping tool. here. Yeah, and click OK. So it's working, and it just will multiply each pixel value with a floating point in meters to 10, and the output will be, see, the also floating point value from 14 to 469. So it's 10 times bigger. 10 times bigger than our input raster. Now we can see the results in centimeter and decimeters. Write down the created expression you formulated in the raster calculator dialog box. So we took elevation, so output, right? Output equals elevation multiplied to 10. Here's our expression in dialog box, which we wrote in a raster calculator. You can also select raster cells with the raster calculator using relational and Boolean operations in the expressions. Note, when you press the equal button in the raster calculator, a double equal appears in the expression. This is normal raster calculator syntax. So we should remember that raster calculator had its own syntax. Let me just first introduce a little bit to raster calculator window. Here is our layers and variables, which in raster format, which we can use. Now here the additional raster output have been created. So here's our dialog box where we can write different expressions. Here's our where our output raster will be stored. Here's numbers and mathematical and Boolean expressions and logical expressions as well. And here in this box we have various tools: conditional, count, pick, set, null, mathematical, float, exponential, logarithms, power, in case you couldn't find them here, trigonometric also, etc. So raster calculator gives you a lot of opportunities to manipulate with your raster data. You can also select raster cells with raster using relational. Okay, it's not a question. So I create an expression in the raster calculator with which you select buildings. Value 1 located on sites that have an elevation of more than 30 meters. Write down the expression. So now we have a question that involves using two input data sets. First, we have land use and land cover, right? We just could uncheck it here. So we have land use and land cover raster data, and we have also elevation in meters, right? Which are spatially fully coincide with each other because it's the same area. See, it's the same area, and pixel resolution 10 and 10, and also here pixel resolution also should be 10 and 10. So it's the same area but different thematic layers. So create an expression in the raster calculator which you select buildings, well, one located on sites that have an elevation of more than 30 centimeters. Write down the expression. So in our land use and land cover we have buildings, right, with red color, building pixel values, and we also have elevation. And now we should find the areas of buildings which are situated on the elevation of 30 meters and more. So now we will write more complicated expression in the dialog box. So LULC equals, it's equal to 1 because pixel value of buildings is 1. And we also use this logical operation, and elevation is higher than 30 meters, right? So LULC buildings 30m. So let me just snip this.